Now, the first thing I want to do when we embark on this two-dimensional journey here is compare what a sphere looks like in two dimensions. It might actually seem a lot more familiar to you. So now let's think of a center for our sphere. Let's just take the origin, right? And now think about all the points that have the same distance away from that center. Well, it's just going to be a circle, right? It's if you take, for example, a rope and you tie a pencil to it and you draw, like, anyways, that's just a way to think about it, because it just ensures that every single point you draw with your pencil has the exact same distance, and it just so happens that it looks like a circle.
A compass. Like if you've ever used a compass, for example, you'll know exactly what this is, right? A compass has like a pencil on one side and you have an origin.
Yeah.
So when you're drawing that radius, you're basically saying, okay, everything exactly at this radius is what this sphere contains. Now, I know like we've been talking about sphere for 1 and 2 dimensions, but it might be confusing to some people still, because I think embedded in memory is that sphere is a 3-dimensional object. So throughout this entire episode, and you might have already guessed from when we were talking about sphere in 1 dimensions, we obviously don't mean the three-dimensional sphere, but it is the sphere is an important mathematical object. So the mathematical object sphere and the topological object sphere, topological meaning like the physical, like the algebraic sphere that we know, like the Earth, for example, they're two very different things. So the mathematical sphere is what Parker is talking about and what we're talking about in terms of intervals and circles and all this stuff. But the topological sphere is quite different. So just to get that idea in your head, and just so you know that,
So I actually just thought of something, and I think it'll blow everybody's mind here, and it'll kind of click in a way where you'll be like, "Damn, that's really cool." So, real quick, so we know what a sphere looks like in 2 dimensions. It's just 2 points. Right? Mm-hmm. We know what a sphere looks like. I meant 1 dimension. In 2 dimensions, a sphere is a circle, right? Because all the points along that circle have the same distance from the origin. And then in 3 dimensions, a sphere is like more colloquially, right? It's like a ball, like a soccer ball, for example. Kind of this I guess the only way to describe it is as a sphere, right?
Yeah.
But it's a hollow object, looks circular. Every point has the same distance from the center, right? Now, think about this. As a 1-dimensional creature living in 1 dimension, you see a sphere. It looks like a point, right? Because nothing has a height or a width. You're living along that length, right? You see a sphere, it just looks like a point. A point is a 0-dimensional object. Now in 2 dimensions, you are living in 2 dimensions. That means you can only see like a cross, right? I feel like I can be more descriptive. Because you're living in 2 dimensions, it means your eyes are 2-dimensional, which means that what they can capture is essentially light that is a projection of the 2-dimensional world into your brain.
Maybe another way of thinking. Another way of thinking about this could be like, think about a plane, right? Think about you on a plane now, right? Just visualize a plane, like on a 3D set, for example, or a 2D, whatever. Like you're on a plane, and now you are that 2-dimensional object in the plane. Now, if you're on the plane and you see a plane, because now you're talking about a sphere, right? So like a sphere in 2 dimensions is a circle. So a circle, like you can kind of think about it like, again, like you're seeing something with 2 directions. Now remember, you can move in 2 directions, in these 2 main directions, right? Like this back and forth and left and right. And the circle is also defined in these 2 directions, this back and forth and left and right. So what you are seeing, I'm thinking about it now, this is not a very good example. Because I was thinking about a really good way of describing it first, but now that I'm actually saying it, I'm like, this doesn't really explain it. Because the way I'm visualizing it is I'm just picturing myself on the plane. And like if I'm seeing the same dimensional object that I am, I won't see one of its sides, right? I'll only see the side that's facing me.
Maybe this works.
The direction that's not facing me, I will never see. So even if it's however it's angled towards me, I will see one of the directions, but the other direction I will never see. I don't know if you can really picture that because I can see it in my head, but I don't know if everyone can.
But here, I'll just say what I was trying to say. Okay. And then, maybe I think people will understand, like, thinking backwards.
Okay, let's hear it.
I'll go back to the beginning. So one-dimensional being, you see a sphere in one dimension, you see a point, zero-dimensional object, or it appears zero-dimensional.
Why are you talking about a sphere, though? Like, shouldn't you talk about like a ball? Because we're talking about like an interval.
Just think about it. Just listen. Okay. In 2 dimensions, now you see one-dimensional projections, right, onto your eyes. So you look at a sphere in 2 dimensions, it looks like a line, which is a one-dimensional sphere. Okay. Now, think about a sphere in 3 dimensions. When you look at a sphere, when you look at a sphere in 3 dimensions, you don't see the 3-dimensionality of it, right? What you can actually just see is the projection of that into your brain, which is just like a circle. So you see, when you are living in a physical dimension, you see a projection down into the one lower dimension. You know.
But again, I think that a lot of that also has to do with the fact of how we see. The fact that we see,
I don't think
our brain perceives things. No, I know. I was actually reading some of these posts where people were talking about this exact thing because I was just, reading in prep for this episode. And I was seeing a lot of people are like, well, let's generalize. Because in 3 dimensions, the very common thing is, well, 3-dimensional beings see 2-dimensional objects. Because what is actually in our eyes is a flat screen where there's light being projected on it, and our brain perceives it to be all of these objects. So we generalize the fact that 3-dimensional beings see 2-dimensional objects, the lower dimension. So 2-dimensional sees 1, and 1-dimensional sees 0.